Alright, how you guys doing today? We're going to take a look at example 1b for determining the convergence or divergence of a series using the integral test. So in this particular example, we're going to use the integral test to figure out whether the series converges or diverges. Now remember, first step for using the integral test, you're going to want to take the series, you're going to want to rewrite that as a function. So once we get it in function notation instead of series notation, now we've got to go through these three things. We've got to show that f is positive, so that's the first thing. The second thing is that f is continuous, and the third thing that f is decreasing. Now, in order to figure out the decreasing, of course, that we're going to have to use the first derivative to help us out with that. So let's go ahead and take a look at a couple of things here for this. Now, is f positive? So that very first thing, if we plug a number, because we're starting with n equals 1, if we plug in any number from 1 upwards, this equation, 1 over 4x plus 1, is always going to be positive. So that's good. Now x is continuous everywhere except for at one value. X just cannot be equal to negative 1/4. Other than that, our function is continuous. Now decreasing, of course, we're going to have to get after that first derivative. When you take the first derivative, you'll end up with f prime of x equals negative 4 over the quantity 4x plus 1 squared. So the denominator is always going to be positive because you're squaring that. And this term right here, the negative 4 in the numerator, well, duh, that's always going to be negative. So we're going to have a negative over a positive, which means our derivative is always going to be increasing. Our slope's always going to be negative. So now we've met that third condition for being able to use the integral test. And the integral test applies for all x's greater than or equal to 1. So we have come this far. So next what we're going to do is we're going to use the limit process. So let's just kind of go up here a little bit more. Now with the limit process, we're going to take infinity. So this little guy right here, infinity, is going to be replaced with b. And we're going to take the limit as b goes to infinity. So we're going to use the limit process and kind of work through this. Now you should recognize 1 over 4x plus 1. What do you have to do to solve this kind of integral? You have to use u substitution. That's right. So we're going to head and use a u substitution. And when you do that, make sure, don't just drop this dx piece, because if you drop that dx, no point for you. I know Mr. Muscarella will take off a point. They'll get deduction there, and some of your other teachers will probably do that as well. So we end up with this expression now using our u substitution. So we've got the limit as b approaches infinity of the integral from 1 to b of 1 over u and then 1/4 du. So that's what our integral translates to when we use that u substitution. Now the 1/4, I mean, we can just kind of move that in front, but the integral of 1 over u du, of course, is just natural log. Now, what we have to do is we're going to back substitute in that 4x plus 1 is going to go in for u. Now, when you do your u substitution again, make sure that you show that, because if you just randomly pull a u right there and then back substitute in, so you've got u's here and then you back substitute in, you've got to make sure that you show the person who's reading your paper what substitution scheme you use. So you got to make sure that you write all that in there. Now when you evaluate this from b to 1, you're going to end up with this expression right here. And then when you plug infinity in for b, well, this piece, of course, right here, this little piece, you know what that's going to do, don't you? You should. That's just going to go all the way to infinity. And of course, the next piece is going to be negative 1/4 natural log of 5. Oops, forgot that piece there, this term here. So I was typing too fast, should be minus 1/4 natural log of 5. And of course, if you have infinity minus a number, you are going to get infinity. So your final conclusion, of course, is that the series from n equals 1 to infinity of 1 over 4n plus 1 diverges by the integral test. All right, so that's it for example 1b. Let's go ahead and take a look at example 1c in the next video. Peace.